Welcome you all for the another lecture on process calculation and unit operation. So today we are going to see about flocculation, sedimentation, settling theory, and then clarifiers and thickness. So these are all the part of a unit operation called filtration and sedimentation. So this is what we are going to see today. So first topic what we are going to see is flocculation and sedimentation. So both this flocculation and sedimentation are by word it is same. The mechanism is going to be the same, in which you are going to separate solid and liquid. This is the objective of both this flocculation and sedimentation. In flocculation, the particles will join together and it will become an aggregate, and then it will get settled down. So this is called flocculation, and sedimentation is the gradual settling of the particles by means of a operation called gravity. So because of the gravity, the particles will have a tendency to settle down. So this process is called sedimentation, and in case of a flocculation, the particles will aggregate together and then it will settle down. So this is called flocculation. So we have a different mechanism for this filtration, for this sedimentation, for this flocculation. First we will see what is flocculation, and then we will move on to the sedimentation and how the particles is getting separated and it is getting settled down at the bottom. So today's topic is about flocculation. Flocculation is a process wherein colloids come out of suspension in the form of flock or flake. Flock or flake are nothing but the small aggregations of the particles. One or two particles or three particles will join together and it will make as a group. So this group we call it as flock or flake. So either spontaneously or due to the addition of a clarifying agent. How the particles are joined together in the sense, it can join together by naturally or spontaneously, or it can be induced joining. That is, you can add some chemicals so that the chemicals will induce the joining of the one or two particles. So when the particles has been joined together, this joined particles or group of particles is called flocks, or we can call it as flakes. So these are settled down, and this process is called flocculation. The action differs from precipitations in that prior to flocculation, colloids are merely suspended in a liquid and not actually dissolved in a solution. So the major difference between your sedimentation and flocculation in the sense, sedimentation and precipitation, both in this process, all the particles will settle down at the bottom and no particle will be suspended in the liquid. So the ultimate aim of this filtration or sedimentation is going to be the separation of the liquid and solid. So suppose in case of your sedimentation or precipitation, all the particles will settle down at the bottom and you will get the purified water at the top and a solid sludge at the bottom. But in case of your flocculation, the particles will aggregate together and it will have a tendency to settle down, but it will not settle down completely. Some of the particles will even suspended in the liquid. It is not a complete settling of the particles. The process, if your process is going to have incomplete settling of the particles, then that process is called flocculation, and if your settling is going to be 100%, then that is called sedimentation, or you can call it as precipitation. So that is the major difference between your flocculation and sedimentation. Flocculation means the particles will even suspend. Even if you have an aggregation of the particles have a tendency to settle down, but it will not settle down completely. It will suspend over the liquid. If it is an incomplete settling, then that is called flocculation, and if it is complete settling, then that is called sedimentation. In the flocculated system, there is no formation of a cake since all the flocks are in the suspension. So since your flocculation system, it is not going to settle down, you will not get the bottom layer of the solid. It will be suspended over the liquid itself. That's what it's given this point. So if you take up a impure water, and if you are going to add some coagulating agent, the particles will tend to aggregate together, but it will not settle down. It will keep on suspend over the liquid. This process is called flocculation, and if you give some time, the particles will have a tendency to settle down at the bottom, and this process is called precipitation, or you can call it as sedimentation. You will get the purified water at the top and you will get the solid sludge at the bottom. Next is called the clarifying agents, or we can call it as flocculants or flocculating agents. So clarifying agents and flocculating agents or flocculants are nothing but these are the chemicals which you are going to add to the impure water so that the particles will aggregate together. and will have a tendency to settle down. So the chemicals which you are going to use to make this flocks or flakes is called flocculating agents, or you can call it as clarifying agents, or you can call it as flocculants. So these three are same. These are nothing but these are the chemicals which you will use to settle down the particles, or to make the particles to join together. 3 or 4 particles will join together so that it will become a flock, or you can call it as flakes. So clarifying agents are used to remove suspended solids from liquids by inducing flocculation. Particles finer than 0.1 micrometer in water remain continuously in motion due to electrostatic charge. So why we are going to add this, or why we are going to make this flocculation process in the sense, if the particles are very fine, these particles will not join together and it will not have a tendency to settle down. So if you want to have 100% pure water, that is without any fine powder also, then we need to make these fine sized particles to settle down. If you want to settle down this kind of fine sized particles, these will not settle down because it will have a opposite charge particles over its surface, so that it will repel each other, so that it will not join together. So to make your particles, that fine particles, to join together, you need to add some chemicals. So this chemicals, what it will do is it will remove the surface charge so that the particles will join together. So if the particles will join together, then it will become a flock and it will become heavy, and then it will get settled down. So this process is called flocculation. Flocculants or flocculating agents are chemicals that promote flocculation by causing colloids or other suspended particles in the liquids to aggregate, forming a flock. Flocculants are used in water treatment process to improve the sedimentation or filterability of the small particles. So during settling of the particles, we have different zones of settling. That is, first zone we call it as discrete settling, and second zone we call it as hindered settling, and third zone we call it as flocculant settling, and then we call it as compression settling. So all these 4 zones will be there in case of your sedimentation. So if your particles is going to settle down, suppose if you are going to take a beaker of water and if you are going to put the sands, these sands will not join together and it will settle on, each and every particle in the sand will settle on its own velocity. So this individual settling of the particles, we call it as discrete settling. Discrete settling means particles will settle down individually, that is called discrete settling. And in case of your flocculant settling, you will make the particles to aggregate together. 1 or 2 particles or 3 or 4 particles will join together and it will become a flock, so that it will become heavy and then it will settle down. So if this kind of settling is there, then that settling zone we call it as flocculant settling. And hindered settling means if the flocks of bigger size, flocks means it will be smaller size, and if your flocks becomes a bigger size, and if it is going to occupy the entire beaker of water and it will not allow the water to move, then that kind of settling is called hindered settling. So that if your particle is going to be heavy and if it is not allowing the water to move, then that kind of settling is called hindered settling. And compression settling is the last settling. In this we have a thickened layer of the solid particles, because the layer by layer the particles will go on. If you are taking the bottom of the beaker, the layer by layer the particles, solid particles will come and cover up the layer. So you will have a very thickened layer of your solid, and this thickened layer we call it as compression zone. So this compression is happening in this zone, so that we are going to get the thickened layer of the solid sludge. So if you see here, so we are going to have 4 zones. First zone, here the particles are settling at individually, this is called discrete particle settling, and here the particles are settling as a group, then we call it as flocculant settling, and here it will not allow the particles to move on, so we call it as hindered settling, and here the particles are heavily dumped, and so that it will become a compression has been given to the another layer by layer the compression is being given, so that this settling zone is called compression zone. So if you see here, discrete settling, the particles are settling down individually. In case of flocculant settling, the particles are joined together and then it is settling. In hindered settling, these flocks will become a bigger size and it will not allow the water to move on. So the particles will be dense in this hindered settling. So this is the different types of settling we have. So if you take sedimentation, we are having 3 types of sedimentation. One is type 1 sedimentation, another one is type 2, and then type 3 sedimentation. Type 1 sedimentation is characterized by particles that settle discretely at a constant settling velocity, that is individual settling of the particles. In case of type 2 sedimentation, here the flocculants is settled down. So if the flocculants is going to happen, then that kind of settling is called type 2 sedimentation. And type 3 sedimentation is zone sedimentation. In this, the process at higher concentration. So the particles will be very heavy and settle as a mass, and distinct clear zone and sludge zone are present. So you will get a clear liquid zone and clear water zone, you will get clear solid zone you will get. So example for this type 1 sedimentation is sand and grit material, and type 2 is alum and iron coagulation, and type 3 it is flying softening sedimentation, active sludge sedimentation, and sludge thickener. So these are the areas where you can find these types of sedimentations. So sedimentation is nothing but it is the tendency for the particles in suspension to settle out in the fluid in which they are entering and come to rest against a barrier. This is due to their motion through the fluid in response to the forces acting on them. These forces can be due to gravity, centrifugal acceleration, and electromagnetism. So sedimentation can be happen in three ways. One is by natural, that is called gravity, and another one is by induced motion, that can be in two ways. One is centrifugal and another one is the electromagnetism. So these are the three possible ways by which you can able to carry out the sedimentation process. So sedimentation process is nothing but your particles is going to settle down at the bottom and you are going to separate the liquid and solid. So these are some of the flocculating agents which you can add to make the flocculation process. One is alum, aluminum chlorohydrate, aluminum sulfate, calcium oxide, calcium hydroxide. So like this we have different flocculating agents we have. When you add these flocculating agents, the particles will have a tendency to aggregate together and then it will become a flock, so that it will have an easy method to settle down at the bottom. Now we will see what is settling theory. So settling theory is nothing but, so as we have seen in the sedimentation, we are going to have four different zones of settling. One is discrete settling, another one is flocculant settling, another one is hindered settling zone, and last one is compression zone. So all these four zones we are having. So each zone will have a different unique settling velocity. That is, it will have a speed of settling of the particles in its zone. So we have to find out that speed, that is velocity, then only we can able to carry out the design aspects of the settling tanks, clarifying tanks or sedimentation tanks and all. If you see in this picture, so in a wastewater treatment plant, so in two ways you can apply this sedimentation. One is for water purification and another one is for wastewater treatment. In both the cases you can able to use this sedimentation process. So first we will go for this preliminary treatment, and once the preliminary treatment is over, then we need to go for the secondary treatment. In this secondary treatment, we first step what we are going to carry out is called the coagulation. So this is called the coagulation chamber. So after this coagulation, it is coming to the flocculation chamber. In this flocculation chamber only we are going to add the flocculants. So once you add this flocculant, the particles, individual particles will aggregate together so that it will become a flock, and then it will have a tendency to settle down. So once it has been become a flocks, then it will be move on to the sedimentation basin. So this is called sedimentation basin. In this sedimentation basin only, all the flocks and the individual particles will settle down at the bottom, and you will get the purified water at the top. And this purified water will go to the further filtration, depends upon the purity that we need. Suppose the filtration is the last step. So before to filtration only we are having the sedimentation. In sedimentation we will get some 60 to 70% pure water, and if it is enough, then we will wind up the treatment process. But if you need some 99% pure water, then you need to go for the further filtration process. Suppose if your expectation is 95% or 99% pure water, then you need to go for membrane filtration. In this membrane filtration only you can remove some bacteria, some microparticles, all those particles you can remove it, and you can have ultra pure water. Ultra fine membrane filtration you have to use it. So this sedimentation basin only we are going to see. So normally we have three types of sedimentation basins. One is circular, another one is rectangular, and last one is square. So circular in the sense it can be of diameter of 15 to 300 feet and a depth of 6 to 16 feet. And typical sizes in industries what they are using is 35 to 150 and 10 to 14 feet depth. In square in the sense it is width is 35 to 200 feet and depth is 6 to 19 feet. Rectangular means depends upon the sludge removal mechanism. Sludge removal in the sense what method you are going to use to remove the sludge. So depends upon the method you can fix your rectangular dimensions. Then next one is called freeboard, where that freeboard should be 1 to 1.25 feet for circular and square tanks. So freeboard in this freeboard is nothing but it is the empty space that we are going to give at the top of your wastewater. Suppose if you are going to have a circular tank and if you are going to fill it with the wastewater, and above the surface of the wastewater, what is the amount of space that is available? That space is called the freeboard space. So simply it is the distance between the surface of the water and the rooftop. So in these two things, this distance is called the freeboard distance. So this distance should be 1 to 1.25 feet, then only we can have a good sedimentation process. So what are the things that we need to see if you want to carry out 100% sedimentation? That is, if you want to separate 100% of the solid and the liquid, or the best efficiency out of this sedimentation. First thing what you need to check is what kind of particles you are going to settle down, whether it is a discrete particles or it is a flocculent particles. So discrete particles means whether it is an individual particles or whether it is a flocculent, that is group of particles. The next one is whether the wastewater is highly concentrated or less concentrated, diluted one. So these are the four things that you need to check before getting into the sedimentation process. One is whether the particles is discrete or not, and second one is flocculent or not, third one is highly concentrated or not, the fourth one is diluted solution or not. So these are the four things we need to check. If we check this thing, then we can able to develop a good sedimentation process. Normally in sedimentation tanks, we have four zones. One is inlet zone, settling zone, sludge zone and outlet zone. If you see in this sedimentation basin, we are going to have an inlet zone. In this inlet zone, we are going to pass all the wastewaters, and this is the area which it will be of bigger area. In this only all the particles will have a tendency to settle down. That's why it is called settling zone. And when the solid particles have been settled at the bottom, this zone is called sludge zone. And once the sludge zone has been developed, then the remaining liquid will move on to the top and then it will be collected in the outlet. So this zone is called outlet zone. So mainly four zones we are having. One is inlet zone, settling zone, sludge zone and outlet zone. First one is called inlet zone. Should dissipate the influent energy, distribute the flow, mitigate density currents, minimize sludge blanket disturbances. So inlet zone, how your inlet zone should be in the sense, it has to dissipate the water equally throughout the sedimentation tank. So if it is a zone in which your wastewater is going to come inside the sedimentation basin, so this inlet zone should make sure that every corner of your sedimentation basin received the wastewater. So in such a way you need to design your inlet zone, and then it should minimize the density current. Density current in the sense, if you are going to have oil and water mixture, then you should have a difference in the density should be minimized. And then last one is it should not disturb the sludge blanket. Sludge blanket in the sense the bottom layer has been covered up with the solid particles, and if you are going to disturb that solid particles, then it will again suspend over the wastewater. So we should not disturb that one. So such a way we need to pass the wastewater in the particular velocity, optimum velocity, such a way that it should not disturb the active sludge blanket. Inlet structures are designed to uniformly distribute the influent suspension over the cross section of the settling zone. For rectangular basins, full width inlet channels, effective spreading of flow introduce a vertical velocity component into sludge that means resuspend the sludge. Inlet channels with submerged orifice. For sedimentation tank followed by flocculation, width of the flocculation basin should be equal to the width of the settling tank. Depth of the inlet channel is equal to the depth of the flocculator basins. So these are some of the design concepts we should follow in order to develop a good effective sedimentation basin. Suppose if you are going to have a submerged orifice in the sense your inlet zone is going to be down the wastewater. If it is going to be at the top, you can design it as like you want, but if it is going to be at the bottom, then you need to carry out some dimension equations, then only you can have a good settling sedimentation tank. That is, width of the flocculation basin should be equal to the width of the sedimentation tank, settling tank, and then depth of the inlet channel is equal to the depth of the flocculator basin. If these things are there, then you can have a submerged orifice. Pipe connection between the flocculation unit and sedimentation should be low velocity pipe, settling of floc, high velocity pipe, break of the floc. So floc means it is group of particles. If you are going to pass the wastewater, that is flocs, in high speed, the flocs will get separated. That is, the group of particles will separated into individual particles. So you need to lower down the velocity so that the flocs will be always flocks, and since the velocity is low, then the flocks will have a tendency to settle down. So this thing you need to optimize the velocity of the sending the water inside, that you need to optimize, then only you can have a good separation. Permissible flow velocity to maintain flock suspension is 0.15 to 0.6 meter per second. If sedimentation tank does not adjoin a flocculator, inlet channels with submerged orifices do not extend down the full depth of the tank. For circular tanks, it should be of radial flow. So because it is going to be in the circular direction, to achieve a radial flow pattern, influent is introduced in the center of the tank or around the periphery of the tank. So in circular tanks, you can have two inlet zones. One you can introduce at the center, so that the water will reach the outermost circumference, or you can introduce the water at the outermost circumference so that it will meet at the center. So two ways you can introduce the water. Central feed means water enters a circular well designed to distribute the flow equally in all directions. D of the feed well should be equal to 15 to 20% of the tank diameter. Depth is equal to 1.1 to 2.5 meter. Velocity through the orifice on feed well is 0.075 to 0.15 meter per second. Entrance pipe suspended from bridge or encased in concrete beneath the tank floor. So next one is called settling zone. So this settling zone, if you want to optimize, then you need to follow these four parameters. One is settling characteristics of the suspended matter, surface loading, overflow rate, width bar length ratio or diameter. Then the last one is detention time. These parameters you need to check to design a good settling zone. Then the last one is called sludge zone. In rectangular tanks, the bottom is slightly sloped to facilitate sludge scrapping. A pair of endless conveyor chains bridge type mechanism continuously pulls the settled material into a sludge hopper where it is pumped out periodically. Motion of scrapper momentarily releases lighter particles a few centimeters above the scrapper blades. Excessive horizontal velocity, or the case of rectangular basins, they move these particles towards the outlet zone. So sludge zone, normally this bottom of the sedimentation basin is going to be designed as a tapered one. So if it is going to be a tapered one, then the particles will, wherever it is going to settle down, it will come at the meet at the center. If it is going to meet at the center, then you can easily collect all these sludge cakes using a pump. So for this purpose, we are going to have a tapered bottom. So this tapered bottom will help you to have a sludge that is formation at the bottom. So wherever it is formed, it will slide down to the center. So it will slide down to the center so that it will be connected to the outlet flow pipe, and this outlet flow pipe is going to be connected with the pump, and this pump you can able to collect all the solids out of it.